welcome to this session, Prevention is Better Than Cure, What's on the Horizon for Biomarkers of Aging. So I'm Professor Janet Lord, and I'm the Director of the Institute of Inflammation and Aging at the University of Birmingham. And I also direct the MRC versus Arthritis Centre for Musculoskeletal Aging Research. And I've got a real interest in how we determine how well somebody is aging, and if they're not aging terribly well, how do we do something about that? So I'm going to ask my co-panelists to introduce themselves. So we'll begin with Dr. Sarah Ward.
I'm Sarah Ward, and I'm the Chief Operating Officer for Oxford Academic Health Partners, which is our local name for one of the NIHR academic health science centres, of which there are 8 in the NHS England footprint. Our particular interest is, of course, supporting and facilitating collaboration across both the 2 trusts in Oxford's region and the 2 universities and the AHSN, and to particularly support those collaborations in accelerating the testing of innovations for healthcare and patient benefit. And amongst our major challenges are multimorbidity, aging, mental health, and the best use of digital in all those areas. So I'm looking forward to an interesting conversation. I've enjoyed very much hearing some of the earlier talks.
And Ranulph Crook.
My name's Dr. Ralph Crook. I'm an NHS GP, and I also recently set up a clinic with a colleague, another GP colleague of mine, Dr. Andrew Crockett, where we really have a focus on healthy aging. And I think Thomas Jackson earlier sort of differentiated what he referred to as the unhealthy aging process, that you're looking for the early stages of disease and trying to pick that up early, versus he referenced a study in France where they're looking more positively at the positive process of aging well. And as he indicated, as a geriatrician, he would be looking at the unhealthy side of aging. And I guess where we would stand would be very much looking at the healthy aging and trying to come even further forwards than the early stages of disease, and maybe looking at those hallmarks of aging to try and pick up that latent period even before a disease has had a chance to develop.
Mm-hmm. And then last but not least, Wenhua Li.
Thank you. My name is Wenhua Li, but everybody calls me Li, so much easier. I am the Chief Executive at Action Against Age-Related Macular Degeneration, or AMD, which is the leading cause of sight loss in the developed world. Even though you might be aware that there are some treatments for late-stage AMD, there's nothing actually to prevent early AMD progressing to late sight-threatening stages. AMD costs the UK economy about £2.6 billion a year. And with the aging population, that's going to be very much unmanageable and unfundable. So the objective of our charity is really to find an intervention that we can go early to preserve health, than trying to really going into the firefighting mode of trying to fix or reverse AMD once already established in its late stage.
Thank you. Okay, so to set the scene then, what we're really thinking about here is really several issues. So if we are going to, at some stage, develop interventions to prevent age-related diseases, whether singly or multimorbid, then we need to know when to intervene. We need to know who to intervene with. And in order to do that, we really need to know, I would suggest, really how well somebody is aging. And if we are to intervene, how well the intervention has worked. I think you can all imagine that perhaps doing a trial that lasts 10 years is not going to happen. So perhaps some early biomarkers of the outcomes of the patients is really something we need to be thinking about. And it will have come across in Thomas Jackson's talk, but this is really something that's bedeviled the field for really decades now. And so really the first question I'm going to throw at our panelists is, what do you think an ideal biomarker of healthy aging might look like? Are we sticking to things like functional biomarkers, grip strength, blood-based, biopsy-based? What might we be looking at? What would be the ideal biomarker for you? If we'd like to start, Sarah, would you like to start?
Yeah, well, my thoughts on that is to be quite sort of basic, that it needs to be cheap and easy to obtain. So if we can't track whatever the marker is through some form of blood, urine, saliva, or other easily accessible source to measure something, and it would have to be measurable, and it needs to be manageable then at scale, because you're looking at potentially having to put a number of people through this process, and then acceptability to both the individuals being tested and the clinicians who are doing the testing as a mechanism to catalyze changes in behavior in many cases, which will not see any benefit until later. If you're being told when you're in your late 40s, 50, that you need to get out there and run more often, because otherwise when you're 75, you won't be able to get up, is quite a hard ask. So, and it's also, final thought I had on this matter was that the most likely case will be we'll need to be testing a series of markers, and that these will evolve over time, because as we learn more, which we will continue to do, we'll adjust what things we track.
Do you think there might be different biomarkers, Sarah, for perhaps different aspects of aging, that you might have one that's really focused perhaps on the others that are a bit more on the physical function side? So it could be a suite that's needed.
Exactly, a suite of things which would suit. And I mean, the ambition seems to be that we would come up with some kind of constellation, that if you had A, B, and D, that your outcomes were likely to be different to if you had A, C, and E. My jury's still out on whether that's actually going to come to pass. I'm a bit skeptical about the utility of that, although that would be a nice solution for policy.
Okay, so Wenhua, do you want to have a go at this one then? The ideal healthy aging biomarker.
Absolutely. And then, look, I love to build on what Sarah has already said. But on top of that, I think we need to be aware that these needs to be non-invasive, right? Fast and cheap, it is all right. But people don't like to be prodded with needles or pull the piece out of them. But more importantly, if we have to do this kind of data collection, as Sarah mentioned, needs to be at scale, but it also has to be very high content or content rich. So we do it once and we can extract a lot of features and parameters out of that one operation. But also is important, and then I will come back to perhaps, probably down the line, we will have a discussion about baseline, right? What is healthy? What is not? What is aged? What is not, right? You can see healthy aging as Schwarzenegger healthy or as Trump healthy. We don't know. So in different parameters, those are still healthy people. And finally, needing to actually access enough sampling to ensure sufficient statistical power for whatever feature we want to extract. If we start doing from, say, let's measure pulse, and then just pull a number out of thin air, we'll never get enough data points. It'll always be short. We just need to have an excess so we can cut it down and be able to do so. And finally, has to be quantifiable. There's no point us trying to get very vague, subjective parameters. It needs to be quantifiable, therefore registerable, annotatable, can be annotated, and labeled, so we can start training AI machine approaches.
Okay, and then Ranulph, anything to add to your healthy biomarker?
Yes, I guess part of what we need to think about is what the use is going to be, and how you're going to use that biomarker at the end of the day. Because a biomarker that you might use, for example, to replace a big long 10-year longitudinal study where you're looking really at the development of a drug and does that have an impact on the aging process, versus if you're trying to pick up one of the hallmarks of aging in an individual and really institute some behavioral changes. So whereas for one, you might be looking at a panel of blood, saliva, urine tests. For an individual trying to make various lifestyle or behavioral changes, you might want something that's a little bit more immediate, a little bit more actionable. For example, a recent study this year used machine learning to see whether you could correlate physical activity trackers with some of the biological age clocks, like the epigenetic age clocks, and found that actually you can get a very accurate picture with something as simple as a physical activity tracker, and then you can update it on a weekly basis. Whereas if you're even talking about blood tests, you're not necessarily going to get people to succumb to a blood test every week to get an update on how you're responding, whether that behavior you just changed has been a positive one or not. So getting an update every 3 months is very different to having a weekly positive feedback on your behavior. So I think it depends on the context to a degree.
Yeah, and that sort of hit on something that made me think of something that Sarah said about, perhaps the acceptability of the test. Do you have any feeling from your practice whether, I don't know, something like being told you've got a blood test and you're going to have to change your lifestyle because your trajectory isn't good, you're heading for an early aging process, versus something like a physical activity tracker? Do you have any feeling about something that might change behavior, is more likely to change behavior, might be something like a blood test or an epigenetic test, whatever? Don't know if any of you got any feelings about that.
I guess in terms of highlighting to somebody that there's maybe an advanced aging process, and you've got something that can really quantify your biological age versus your calendar age. I think as long as that accurately highlights that there's something that needs actioning, that's useful information. But the more detail you can kind of infer as to maybe what process is going on. So if you can specifically identify which of the hallmarks of aging might be going awry, mitochondrial dysfunction or impaired nutrient sensing, or epigenetic alterations, then you might be able to then sort of target your interventions a little bit more accurately. But I think in terms of acceptability, if you can do a one-off test to really quantify that, but then use something like physical activity tracking to reinforce those lifestyle changes, it might be, as we were talking about earlier, that there's an array of tests, a little bit like we used to have single gene mutations which inferred a risk of certain cancers, but now polygenic risk scores are much more accurate, and so a similar sort of thing with biomarkers.
To add to what I was saying, if I may, one question, one of my friends who's a yoga instructor has given me this one, that said physical fitness is actually not an absolute thing. It is a description of something which you are able to do. You have to be fit enough to do the things you want to be able to do, and the things you might want to be able to do in later life are maybe not quite as ambitious as they are in your 20s. So it is very much to that question of what the individual wants to achieve from their longevity. And Thomas showed a lovely slide of all those different old people, and there's no such thing as a typical old person. Rather, a typical person of a certain calendar age rather than aged.
Yeah. And I think another thing that comes out of this, what do you think are our current capabilities on the prediction and monitoring of aging and health span? Where are we now? I mean, Ranulph might know as a GP. I mean, I know we do the e-frailty monitoring, I think, but where are we actually with being able to predict and monitor the rate that somebody is aging already?
I think we already use quite a few of the biomarkers, as you say, with frailty scores, and using cholesterol to kind of give a heart disease risk score, and blood pressure and BMI and things like that. In terms of looking at the underlying sort of hallmarks of aging, I think it's less clear. There are certainly some like the epigenetic tests that we were talking about that are correlated with aging and age-related diseases. So those are very much available and commercially available to the public. But I think in terms of then being able to action those and really individualize how you might do anything to impact on those, I think there's still a little way to go. And I think it needs to be something that's cheap and easily accessible to the general population to really have the greatest impact.
Mm-hmm. Wenhua, do you want to come in here? I know as somebody interested in everything visual, there are lots of scanning and AI approaches in the ophthalmology world. So anything from your experience that might really help us and say, look, this is something we could be doing now?
Yes, indeed. Thank you for that question, Jared, because I do agree with what Ralph said. This course parameters, BMI, for instance, muscle strength, etc. Those are easy to gather. And I think we are starting to accumulate enough data to start making that new discoveries, right? Because it would need that amount of information coming in. Before the big data, before easy collection, we didn't have that. So we're just at the cusp of that. But even having said that, I don't believe there's much more we can discover on top of those really coarse data sets. On the other dimension, I'm trained as a structural biologist and worked in drug development for a long time. And we know how very quickly we can go down the rabbit hole of, and look, I love epigenetics markers, but it's so challenging to sequence those, to identify and characterize. And we don't do that in a large enough scale because it's too expensive. It requires a lot of sampling. It's always a snapshot. It's never a continuous movie, if you like, of the evolution. So we're still not cracking that. And yet, there's so many more talks about identifying more and more deep phenotyping, right? So what I like to bring this table is that let's not forget there are meso kind of data collection that is out there. So we were discussing earlier on, we might not think much of the eye scans. However, remember that the eye itself is an extension of the brain and is the only transparent window into your inner systems. Luckily for us, through the eyes, you can detect the neural retina, so connected directly to your brain. You can detect microvasculature. You can detect even perfusion, right? And some of the manifestations of inflammation markers could be seen through the eyes. So with one visit, perhaps to your ophthalmologist or to your high street optician, you can get that kind of information extracted. And in a study in 2018 published by a work that Google actually used, a lot of just the simple fundus photography, basically just a picture of the back of your eye, the surface of that tissue. They trained with 300,000 images, but they didn't know that using that set, they could not only detect, of course, the retinal kind of conditions, but they found out that they could quantify age with the mean absolute error within 3 years. That's impressive. No one knew that could be done through an eye picture. Gender, AUC of that is 0.97. It's almost infallible. Okay, this is really accurate. Major adverse cardiac events in the past, AUC of 0.7, and even systolic blood pressure down to an error of 11 millimeters of mercury. That's within the normal measuring error. So you can get all of that information through this one single extraction, cheap, non-invasive. People accept culturally. No one's prodding a needle in your arms. So I think we should start looking at those meso collection points that we can get, right?
And has that data, you said that it could get the age within 3 years. Was that the chronological age or?
Chronological age.
Look at future development of disease or age that might tell us the biological age of the individual?
Perhaps it needs to be calibrated there, but they just basically had the images and the chronological age on the patient kind of information sheet. But if we start building either polygenic risk scores, etc., then we can go what Ranulph suggested. You have very sophisticated definition of what different aging process might be, but have a much cheaper and readily accessible surrogate markers. But in order to do that, you have to have a lot of data here at the sophistication and a lot of data here at the coarser level or meso level.
Yeah. Sarah, do you want to add anything about what we might be able to do now?
Well, I think we can do quite a lot of things now that are functionally related to certain disease courses or constraints. You know, we're not about the aging of the kidney and the heart, of those sorts of things. What we don't have is something to tackle the spectrum of multimorbidity that we see in the aging population. And the problem with that is in part the fact that we are going to take a while to get there. So that isn't going to benefit the current aging population, really. Past the boat has already sailed on that one. I was interested in the comment that was made in the first talk about what point would we say we would need to take some kind of soundings or evidence base. If that would be in your early 50s. I remember in my days back in the clinical genetics lab at St Mary's in Paddington, we used to think that that would be the thing that would happen at 40. You would have some form of screenings test that would tell you what your likely cancer prognosticators were, and not just for cancers rather than for anything else. Another thing we have actually discussed as a group was this question: if you're doing this sort of screening, you may reveal information that people don't want to have or that you don't really want to share with them. I think somebody called it incidentalomas or something like that, which is all related to that. So it seems as if it's very diverse. We have lots and lots of knowledge in some areas and really none in others.
That's a good ethical question, isn't it? You know, if you're telling a 40-year-old they're biologically 50, is that something that the patient may want to hear? Or I guess some would act on it and it might be a wake-up call, but others perhaps would rather not know. Yeah, interesting. So moving on then, so we've sort of said we're probably not there yet, but do any of you have an example of a biomarker? So we've already heard from Wenhua, one example of a biomarker that might be useful at the moment. Any examples that you've seen or think could be done? And also at scale, thinking at scale, what might we be able to do now? Is it good old grip strength? Are we stuck there? Is that where we are? Or could we actually do something now? I'll start with Sarah this time.
I'm not sure I have anything to offer to that particular thing, but maybe be more nuanced ways of deciding who to test with what. Certainly in brain health, there's been some interesting work going on in the Brain Health Centre in Oxford of bringing together a sort of inter-triage what were two forms of referral into that section and doing that all through one space. So it may be that we need to be a little bit more focused and centred around doing the analysis, but I wouldn't offer an example of a test, I don't think.
Yeah. Ranulph?
So yes, I guess there are, in terms of thinking about rather than picking up early stages of unhealthy aging, multimorbidity and frailty, in terms of checking your biological age, that there are a number of tests that are currently available and scalable. So there are ones that utilize commonly used blood tests like the PhenoAge and the GrimAge blood-based clocks. And again, the price of epigenetic testing is coming down all the time, and really, those sorts of things do give a degree of actionable data. You can see that there are changes, and certainly very much interested in the machine learning side of things. And if we can, develop machine learning programs that are accurate enough to simply feed in somebody's wearable physical activity data to give real-time feedback about how that is impacting on their sort of rate of aging, I think that's something that is very acceptable. It's very cheap because at least a quarter of us all have those, and since COVID, the number of people with wearable tech has massively increased. So it's something that's cheap, easily accessible, and very, very acceptable as well. So those sorts of things are very much, pretty much there, and something that could be applied quite widely.
Yeah, I think you comment about the pheno age and grim age. I mean, we're, probably most GPs are sitting on that data already.
Exactly.
And it could be used. Yeah. Wenhua, have you got anything to add other than optical scanning?
Well, I don't like to sound like a broken record, but on the optical scanning, well, I think one thing that, even though I mentioned, those more general markers or historical of different diseases, there's actually quite a few proof of concept, because those images are readily available and have been used by AI groups to try to extract value. They've actually been a lot of proof of concept showing that you can use eye scans to detect early forms of Alzheimer's. Okay, of course, all of these I'm talking to you needs to be further validated in a larger population. But these are very promising examples. I mentioned cardiovascular conditions, renal conditions based on microvasculature. You can almost predict the cardiac risk, right, for these many people just through the eye scan, and even possible neurodegeneration, because these machines now, these scanners, can look at the thickness of your neural retina, basically the neurons that sit on the top of your retina to detect the light. Has been correlated that thinning of that retinal layer could imply to lower cognitive function. So now thinking about the potential, instead of actually doing all the tests and scores, which are subjective on Alzheimer's, and then send someone to MRI to measure brain shrinkage or whatever, you can just go to your optician and track it. And that can be done every week. Every time you go and pop up to the shops, you can walk into the opticians, zap, right? That I've done it. It's 5 seconds per eye. I think Specsavers charge £10 or whatever to do an OCT, this highly deep 3D scan. And these, I think, is a great opportunity. Think about the capability that the clinical practice now have. All hospitals have those equipment, but they're used for clinical practice. You cannot deploy in the general population to gather that baseline, which we've been talking about. But what about the high street shops? Right?
Yeah.
Again, I'm not saying any specific branch, but just think about Specsavers. You see it everywhere. And if they have a machine there sitting in the shop, even deprived communities or rural communities will have the optometrist.
Yeah. So it could be done at scale.
Yeah. And used for tracking.
Yeah. So what I seem to be hearing is that, if we think of research and development and perhaps moving some of these tests into clinical trials, is your feeling that we've probably got enough biomarkers and we just need them better, or do some bigger scale analysis? Wenhua, do you think biomarkers, or we just need to use them more?
I think we need to calibrate them. We're talking about a very, very gradual process. No one can put a hand on what is aging, right? My dad is almost 80 years old. I'm not bragging here, but he does everything in the house, fixing, etc., etc. But if you look at perhaps comparable people in different countries, they are already having this, I'm just waiting for death to come when they're 65, right? So I think the cultural component is really important there.
Yeah.
I'm not saying that we don't have enough biomarkers, but we have to understand how to calibrate them to see whether we can find those trends.
Yeah. And as you said, perhaps there needs to be some cultural sensitivity as well in there as well, that it's not going to be one size fits all. Good point.
And ethnicity too, because there are different changes, right?
Yeah. So. Yeah. It's interesting. We've just finished a study looking at the age of onset of several chronic inflammatory diseases and found that, in several, Black and South Asian communities, that they develop early, and it's not explained by deprivation. There's definitely something different going on there. Yeah. So it may be that the trajectories of aging are quite different with ethnicity as well. Yeah.
And cultural lifestyle, which is ethnically linked, right? Food intake or exercise levels. So
yeah, definitely. Yeah. Sarah, do you think we need any more biomarkers, or just need to use them better, test them out?
Yes, I think we need to get on with it, basically.
Yes.
I think we need to start introducing that. And I'm not sure that the point I wanted to sort of raise was that question of self-management and the fact that we do have a national health service, but actually we don't. We have a national ill health service where you go when you have something wrong with you. And to what extent we can encourage people to take ownership of their own health by using, as Ranulph correctly said, I have one on my wrist as we speak, a wearable. And getting, or how does a GP use that data to help tell me what I should or shouldn't be doing more of? I think we need to be getting to that, and we are getting to that. COVID has been quite useful in that respect, in that people have been more aware of their health and having to sort of pay attention to that sort of thing. There's been a project on COVID oximetry at home, which has run across the southeast and been really very successful, introduced by the AHSN. Of those 3 regions, and I could see in the future people having a first aid kit that includes a pulse oximeter, a sphygmomanometer, etc., and that they would start to become much more aware. They're already using Google.
Yeah.
So I think we need to get on with it, and those biomarkers will change as we discover new things. So but a bit like we discussed before as an MOT, we do emissions testing now we didn't do 20 years ago.
Yeah. Ranulph, would you be in agreement there? We've got enough. We just get on with it.
Yeah, I think there's certainly some established ones, as we talked about, the blood-based ones, and calibrating them, and the new, more novel ones like the epigenetic alterations. But so I think that they're already ones that, as you say, GPs have reams and reams of data of people's historical blood tests that you can quickly apply the pheno age or the grim age to, and really get a lot of information, and more work can be done that side of things. But I am excited and interesting in terms of sort of seeing whether there are biomarkers that really can identify the different hallmarks, and whether then you can really sort of tune into, rather than saying, yes, your car's working well or it's not working well. It's your brakes, and actually no, it's your clutch, or which part of the machine isn't quite working as it ought to be.
Yeah, and even which of those hallmarks is, specifically driving which of the age-related diseases. We still don't really know that.
No,
we know there are 9 of them, but which ones do we need to hit for, brain health? Which ones do we need to hit for musculoskeletal? So
exactly. Yeah,
still a way to go there. Okay, so I think we've had a bit of a discussion there. It's time that we can open it up to the audience. So if any of the audience have got any questions for our panel, if you could put them in the chat. Yeah. Okay, so we've got one here. Okay. Yeah, what do we need from biomarkers to develop clinical trials for geroscience? So this is the idea of targeting aging processes. Can we measure that success across multiple pathways with currently available physical markers such as gait, grip strength? Yeah, so basically this is asking really, are the biomarkers really good enough for clinical trials? And could we use some of the physical markers such as gait? Does it have to be blood-based? What do you think? Wenhua, do you want to start with that one? Could we go to clinical trials?
Sure. I think it would depend on what you want to measure, right? So if you're thinking about this physical ability, yes, that should be sufficient. But what about the other functions that we're not addressing, but we don't even know? I think that really brings the important point, which I don't think we spoke too much to it, which is the linkage of different biomarkers. We still see biomarkers as different parts. We're measuring pulse, but we're not correlating with, I don't know, we are correlating with saturation, for instance, but no, we're not correlating with anything else other than whatever we have when we collected that data set. So that's why I think it's important, and we should be looking more, for instance, into the Health Data Research UK, which is trying to bring all the health data of the UK available and connectable, hopefully linkable. So you can start to extract what your marker here can tell you about different conditions, right? So multi-parametric kind of try to correlate those. And in that correlation, again, Thomas Jackson pointed out really well, sometimes you hit a marker that can inform you what the disease biology or pathway is without you knowing. So how come I didn't know I could detect age just looking with an eye scan, for instance? That's a small example. And then finally, just to wrap this up, we are working with colleagues already, in Birmingham, Amsterdam, and Stone, in providing the historical data set for ocular scans. But we also need to think about how to tap into, going back to Sarah's point, all the data we have, all the markers we have is secondary care, or at least NHS kind of owned. There's so much going out there which is not NHS. We do have the trackers, which belong to each company that makes those watches. We don't have access. I've just yesterday I read an article about headset like this with noise cancelling. They do have 3 microphones in each, and you can measure the way that the sound wave bounces. You can put a voltaic measurement to see conductivity of the skin for stress measuring, right? Heartbeat, all of those. We're not even looking at that. So we need to integrate with the commercial data providers so we can capture that. And more importantly, what is the healthy? So again, that's a great national project called Our Future Health, which is going to be launched very soon, which is looking at these 5 million people within the UK to get a healthy cohort. I think that's superbly exciting for us to calibrate that baseline.
Excellent. Yeah. Sarah?
Well, the short answer to the question is we need more research. I think we haven't done enough research yet to understand this. The systematic review of the literature that we discussed with the Spine team a little while ago, it shows that there was a lack of consensus about the outcomes the criteria for the outcomes of these things. So although a lot of stuff has been done, it hasn't been directed towards trying to understand aging and multimorbidity better. So the sort of traditional answer is we need more longitudinal studies, and I think there were papers cited in that paper that had done like 48 years of follow-up, and we simply don't have time to allow that length of time for longitudinal studies. So to what extent we can, and I'm not the data geek, but I know there are computational scientists and others who could answer this question better, is how can we leverage the data we've got to try to identify things that we would want to try and test as a suite of biomarkers for predictors of aging.
And certainly I know there was one paper published last year from Steve Horvath's group. I don't know if any of you saw it, where they had a cocktail of 3 agents, metformin, DHA and growth hormone. They gave it to healthy males. I think there were about 12 in it. And after a year, it did drop their epigenetic age and also some of the immune markers as well. So that was quite interesting. But what would happen to those guys long term would be really interesting to know, because I can't imagine you're going to leave them on growth hormone for any length of time. But an interesting study at least. Ranulph, did you have any ideas?
I think, as was mentioned in an earlier session, that it depends on what you're looking for the biomarkers to do, whether that's diagnosis, prediction, response to an intervention, or tracking a biological process. I mean, using grip strength, for example, yes, that might correlate, but if you're going to do an intervention, if you've got somebody who's then going to be eating an awful diet, very sedentary, but they're just sitting there working on their grip strength, does an improvement in their grip strength mean that they're getting healthier? Probably not. They're sitting there not doing all the rest of it, because on a population level it correlates well, but on an individual level, just working on your grip strength isn't going to necessarily improve your health or your lifespan.
Yeah. We've got another question. So this is one that really did the rounds for a long time. Was telomere length? What do you think about telomere length as a measure that could be used in geroscience trials? Ranulph, do you want to start with that one?
So from my understanding, that they had the telomere sort of assessments haven't necessarily been evaluated for aging fully because there's such heterogeneity between different cells. So you get and individuals, so you get a little bit of measurement errors. That it means it's not as consistent as some of the other markers that we've already got.
Yeah, I think you're right, and I think certainly most of that data has come from blood cells, and the telomeres are going to be really affected by how many infections you've had through your life course, which could give you some indication of your general lifestyle, I suppose, but whether it could really tell you, I think, tightly enough, as you said, Ranulph, how well you're aging. I think again, I think it's gone a little bit out of favor, but
Yes,
Sarah?
giving people information that isn't clearly standardized would be unhelpful, because if in one, your cousin in another part of the country gets a completely different spin, then that would be actually more damaging. And have people reduce people's trust in the whole process, I think.
Wenhua, did you have a view on telomeres?
To me, actually, it's trying to use a super complex nuclear clock with precision to time how long the turkey bakes. So we can get many other easier to gather parameters to show aging. We don't have to go down to telomere because it's really fancy, and we don't even know whether that's related to direct limit of longevity, for instance, that has been kind of, let's protect our telomeres and we won't age. Really? Sorry.
Not necessarily. No.
Not necessarily.
Yeah. Okay. The next one sort of comes on from Sarah's point just now. What work do you think we need to do with the patients and public to sort of get them to understand and feel confident about potential biomarkers for aging? I think it's something that we had a session, the very first session today we did with a group of older adults, and most, they don't know the geroscience concept or that there are biomarkers of how biologically old they are. So there's certainly some work that needs to be done there, just in raising general awareness. But I know there are already companies out there, and I think you may have said it right at the start, Ranulph, who will tell you your epigenetic age and things like that. So, is there work that needs to be done with the public, or, educating them that there might be biomarkers to tell them how biologically old they are? Sarah?
Yes, well, I think we've done quite a lot of it. I mean, in that, chronic kidney disease is now turning into sort of kidney age, as opposed to telling you have a chronic thing or disease. Sounds like it's something that you can't get over. Or perhaps worse, that's something that a doctor can give you a pill for that he may or she may not be able to help you with. So I think domesticating the idea that there are now ways of predicting how well you will age, and the fact that everyone will age. It was nice to see Thomas's presentation this morning, or earlier this afternoon, about moving people up into that right-hand corner, and explaining that, I think, to the public would work. I mean, they would have the capability of understanding that, and then would feel more at home with it, I think.
And I guess they're familiar already, aren't they, with cholesterol, with blood pressure, and perhaps just adding something else into the mix there that's just indicating of really how well they're doing, isn't it, really? Some perhaps.
And it goes back to my earlier point of asking them what they want to achieve. I mean, for someone at 75, not being able to run 100 meters is not a problem necessarily. But for others, that isn't the case. They're running marathons.
Yeah, I think you're quite right. It's interesting, we did a Delphi study, it's got to be 10 years ago, across the different populations in Birmingham, every ethnicity. And the one thing that we asked them all, what was successful aging? And the thing that came out was still being able to be involved with their communities and felt that they could still do what they wanted to do. And it didn't, as you say, it didn't matter what it was, whether it was running 100 meters or whether it was being able to take the grandchildren around the park. That was what mattered. It was really interesting. There was less concern about disease. It was just being able to do what they wanted to do. That was really important. Yeah. Yes, that fits to that. Ranulph, as a GP, do you talk to people about their trajectories, or can't you do that in the 10 minutes?
Yeah, it's tricky. I guess when you're trying to talk to people, it's sometimes useful to be able to give them something in black and white. So I think being able to access these things and it does need to be in 10 minutes something that's very easy to do. So whilst yes, for all of my patients I could come out, go into an Excel spreadsheet, put all of their bloods in and give them a pheno age, there isn't the time to do that for them all, and there isn't really that support to get on board with the idea that you can work out whether you're aging well or not, or you've got aging healthily or not, and so I think it's just another tool that you can utilize to maybe sort of encourage behavioral change, because at the end of the day, a lot of the interventions you're going to do are going to be the lifestyle things, just you would do now for picking up people with established heart disease, diabetes, dementia, and all those processes. It's going to be a lot of the same advice and the same information, but if we can pick up those cohorts of people even before they've got any established disease, but give them something that they can track. It's well established that having positive feedback and self-monitoring is one of the greatest tools to enable behavioral change. Then that gives people to take a bit of control for them, especially if the monitoring they have is via their wearable device, and the fact that gives them a weekly feedback on an updated biological age, it just it helps with that behavioral change and is another tool to highlight, yes, we know you don't have this disease yet, but we're not just trying to prevent your diabetes or your dementia. That's the beauty of it. If we're correlating something that works with the underlying hallmarks of ages, rather than just looking at your heart disease risk or your decline, you're looking at something that's going to have implications for any age-related disease, and so you're targeting all of those things at a much earlier stage, because they generally have 10-20 year latencies where you have that big gap of intervention, where unless you've got something to pick up and show somebody and say, look, you're already down on this process, it's a little bit like how we're now picking up much more what some people would refer to as pre-diabetes or impaired glucose regulation. It's even going before the insulin resistance and before that, to say that even before you've developed any sign of a disease, we can see that you're heading that direction. So let's see what we can do something about it.
So I think that's great, and it's just shame in the 10 minutes we can't. So I think, Kyle, if we have any AI geeks in the audience who want to develop a software to automatically calculate pheno age in the GP surgery, I think that would be amazing. So Wenhua, did you want to just add anything quickly? We've just got a few minutes left.
Very quickly, I think it's a great idea to be able to see every day, because not only that get an incentive to actually try to do something that's corrective, but I think there's always this innate nature of gamification, right? We always like to see how we're doing compared to our peers, right? Whenever I have my sleep tracker on, I said, oh, you slept later than most people would have gone to bed, I get worried, right? So it's that kind of level. Try to get that calibration, get that kind of easy to understand. And you're right, people already are used to this concept of biomarkers, but being able to see every day, even if it's small change, at least that it doesn't dip, and rather the numbers are actually starting climbing, improving, is a good sign. Whenever I went to my blood works and I said, oh, wow, your cholesterol is high, the bad cholesterol is high, I would try to observe my food intake or fat intake for the first week or two, but because no one's telling me whether it's going the right direction or not, you give up. But if you can have those trackers to see weekly, I do think that is the best approach for getting people behind.
Excellent. Okay, so just to wrap up then, I'd like to thank Ranulph, Sarah and Wenhua for a great discussion. I think some of the conclusions are that we've already got lots of biomarkers, some of them very complex, such as the epigenetic markers, some of them very perhaps simple to get to, like the optical OCT scans. We should use them more, and perhaps even getting some sort of algorithm for GPs to calculate phenotype bloods. I think that would go down amazingly well with adults. So I'll finish the session there, and thank you for everybody for attending. Thank you.
Thank you for having us.
Thank you.
Thank you, everybody.
Thank you. Thank you to the panel. It's been lovely to hear the discussions this afternoon. It's been an action-packed afternoon full of technical breakthroughs or discoveries of everything we didn't know about running a virtual platform, but also a lot of scientific content as well. I've really enjoyed the focus on biomarkers today and looking at how in the future we can be better armed, both from a patient information point of view through to clinical trials, through to how we use those in R&D projects. I think Thomas's point, to go back to the beginning of the afternoon, thresholds of what marks successful aging and how and when we should be intervening are really, really poignant points. I'm really looking forward to tomorrow now, where we're going to build on today's discussion by looking at the drug discovery element of what we're doing with UK Spine. Because if there's one message that's come across this afternoon, it's that all of this is so interdisciplinary, and all of this will happen and be successful because we collaborate. And tomorrow continues that theme in how we can put everything together, all our expertise, all our capabilities to really deliver in this really exciting field of healthy aging and multimorbidity. So without further ado, I'm going to wrap up the day and thank every speaker and every person who's backstage as well. And remind you all that tomorrow we'll be starting at 1:30, but feel free to join early and have a look in our expo booths, where you can speak to some of the speakers from today and tomorrow and Friday and ask them all the questions you didn't get round to this afternoon. Equally, if you'd just like to have a virtual chat with someone, we have a function where you can chat to anyone. Press a button and you'll get a random person in the networking session. So why not talk to somebody who you might have bumped into over a cup of coffee and a biscuit if we were in person? So thanks very much for joining us today, and we look forward to seeing everybody tomorrow. Bye for now.